Hello, geometry kiddos, and welcome to today's lesson. Today's lesson is one of my favorite of all time to teach. I'm super sad you're not in the classroom to be able to do some of the investigations that we do, but hopefully my freehand drawings will help make this point come across to you. So make sure you stop this video in places where you need to and get things copied down. All right, so when three or more lines intersect at one point, they are said to be concurrent, and that is called the point of concurrency is where they intersect or meet. So you can see these three red lines are meeting at a point. This point right here is called a point of concurrency. Now, just because our first investigation here is going to be doing perpendicular bisectors, that's actually what these red lines are. So if you look at side AB, what happens is this to this is actually at the midpoint, and it's coming down perpendicular. Okay, and then we look at BC, and this point right here, J, is the midpoint of BC, and that red line is coming down perpendicular. And then now if we look at AC, this point right here, W, AW is congruent to WC, and this is coming down perpendicular. So these are the perpendicular bisectors, and they meet at a point of concurrency, and this point of concurrency has a special name. Now, we're going to look at the perpendicular bisectors in three different triangles. An acute one, which is right here, and in the acute triangle, where is that point of concurrency? This is actually called the circumcenter. So the point of concurrency, when you make the perpendicular bisectors meet at a point of concurrency, that point of concurrency is called the circumcenter. And when you make an acute triangle, that point always is inside the triangle. Okay? Now, if we were to measure, take a ruler, and if we were to measure from this point to A, and this point to B, and this point to C, all three of those blue segments would be congruent. So what happens is the circumcenter is equidistant to each vertex. It is equidistant to each vertex. So if I know that AP is 15, then you know that PB is also 15. If you know that AM is 8, then you know that MB is also 8 because that is at the midpoint. Okay, so that is an acute triangle. So what happens when we have an obtuse triangle? And what happens here is when you have your perpendicular bisectors, we'll see how close I can come to making this work. Where's that midpoint? About right here, coming through. Okay, when you have, so that this is the midpoint, so this is congruent, this is the midpoint, so these are congruent, and they're all coming down at perpendicular bisectors. If this angle is obtuse, do you see that this circumcenter, that point of concurrency, is outside the triangle? And what happens is, as this angle right here gets closer and closer to being right, this point comes closer and closer and closer inside. So if we actually have a right triangle, what happens is the perpendicular bisectors come through and they meet at this point right here. They meet, whoops, sorry, not right there, right here. Okay, this perpendicular bisector would come through This perpendicular bisector comes through, and then the perpendicular bisector here comes through. Okay, so if it is a right triangle, they meet at a very specific point, and it's just not inside the triangle like acute, or outside the triangle if it's obtuse. If it is a right triangle, it meets at the midpoint of the hypotenuse. Midpoint of hypotenuse. I'm going to run out of room here. Midpoint of hypotenuse. All of this information I have coming up on a screen. Okay, there's one more thing that I want to show you. So I'm going to go backwards one more thing. And what happens is, if I could have you have a compass in your hand right now, we would put the sharp end right here at point P. And we would open this up so that it would be at A, and you would swing a circle. And what would happen is this circle would go through all of these points. Whoops, bad circle. Would go through all of the vertices, because the distance from here to here, this is your radius, this is your radius, and this is your radius. So a circle would be circumscribed about the triangle. Okay, and it would look like this. Okay, so if we did the perpendicular bisectors, this is acute. So all of your perpendicular bisectors are going to meet inside. Now the distance from this circumcenter to the vertex, that distance, let's just say it's 15. This distance is 15. This distance is 15. The distance to each vertice is the same. It would be 15 units. Okay? All right, let's get to the main screen that has all of this information. So, what we just talked about is the circumcenter. Okay, the circumcenter is the point of concurrency when we make the perpendicular bisectors, see? And with the first triangle, if you have an acute triangle, like the one demonstrated here, that point of concurrency is inside the triangle. Okay, if it's obtuse, that's when that point of concurrency is outside the triangle. And if it's right, it's on. It's more specific than on. It is at the midpoint of hypotenuse. So please make sure you write the midpoint of the hypotenuse. Okay, it's not just on the triangle. It is on the midpoint of the hypotenuse. Okay, what importance is that the circumcenter is the center of the circumscribed circle. The circumcenter is equidistant to each vertex. So from P to A, P to B, P to C, those are all the same distance. And if we were to put a compass end on P, we would be able to make a circle that goes through A, B, and C. Okay, freeze this screen if you need to, and make sure that you are getting all of your information down. There's a lot of it here. All right, I am going to go on. Okay, so a carnival operator would like to place a food stand so that it's same distance from the carousel, the bumper cars, and the Ferris wheel. How can we find a point so we can put the food stand so it's equidistant from each one? Well, what did we just find out? If it's equidistant from each vertex, can't we construct the perpendicular bisectors of each side? Okay, we need to construct the perpendicular bisectors of each side. So BC, find that midpoint, make a perpendicular line. CF, find the midpoint, make a perpendicular line. BF, find the midpoint and make a perpendicular line. This point right here is going to be called the circumcenter. So we're going to do the perpendicular bisectors of each side to find the circumcenter. This is a test question. You need to know that what would be the best thing to find? The circumcenter would be the best thing to find so that it is equidistant from each vertex. Okay, we haven't done any constructions yet, so we might just have to explain these for right now. All right, find the coordinates of the circumcenter. Okay, A is at 0, 3. B is at 0, -1. And C is at 6, -1. Okay, these are my favorite kind of triangles because what kind of triangle is that? This is a right triangle. And what do we know? If we have a right triangle, where is the circumcenter always found? Remember, I had you go write it very specific. It is found at the midpoint of the hypotenuse. Okay, so we really don't have to do a lot of work here because we know that this is a right triangle. We just need to find the midpoint of AC. So using A and C, find the midpoint. Whoops, midpoint of AC. So 0 plus 6 divided by 2, and 3 plus a -1 divided by 2. So what do we get? 3, and 3 plus 1 is a 2. 2 divided by 2 is 1. So that would be right here at 3, 1. So the circumcenter of this particular triangle is at the ordered pair 3, 1. All right, given that point G, okay, they're telling us, hey, we constructed all of the perpendicular bisectors because this circumcenter right here, point G, is there. So that means all of these blue lines, that point D, this is perpendicular, and this is congruent to that. Find each of the following lengths, BG. Remember, from here to every vertex is the same. So if AG is 9, then BG is 9 also. Okay, now if we find AD, let's see, where is AD? AD, okay. Well, that's a midpoint. If BD is 6, then AD has to also be 6. And then the last one that we have here, AC. AC, what do we have here? All right, I can't ponder too long because I'm running out of time. This kind of triangle right here is, remember, is a right angle. This has to come down perpendicular. So I can set up my Pythagorean theorem. 3 squared plus AF squared equals 9 squared. So I have 9 plus AF squared equals 81. So AF squared is 81 minus 9, and 81 minus 9 is 72. So now what we're going to have to do is take the square root of both sides. So we're going to take the square root of 72, and then this comes out to be roughly 8.48, but that's just AF. So now you're going to have to double it. So times by 2 before you do any rounding. And it doesn't say what to round to. This actually comes out to be 16.97. So if they asked you to round to the 10th, we would say that this is about 17. 0.0 would be rounding to the 10th. Okay, this is only half of the lesson in 6-2. This is talking about the circumcenter. The circumcenter is made from perpendicular bisectors, okay? Every circumcenter is made because we constructed perpendicular bisectors. And it depends on the triangle as to where they are. So if it's inside, that circumcenter is on the inside of the triangle, like the one drawn here. If it's obtuse, so if we have an obtuse triangle, that circumcenter is going to be outside. And if it's actually a right triangle, then that circumcenter is going to be on the midpoint of the hypotenuse. Okay? And remember that every single one of these, if you connect from here to a vertex, you can make a circle go around. Okay, just like the red one I have drawn here. Okay, this is half of lesson 6-2. I'll be back in a second.